Hello, good morning, good afternoon, good evening. It's 2022 and my name is Carol Battle and I'm here at Autodesk University this year to talk about how the construction sector will get to net zero. I'm a part of the Autodesk Consulting Sustainability practice and working out of APAC. And the reason I say 2022 is because we expect things to change in this space and we expect them to change rapidly. So it will be interesting to look back from the future to see what was projected and where we were at this time. As with all presentations, we will start with the safe harbor statement. And in today's presentation, we aim to outline a range of things that will help you learn. I hope that you walk away from here learning about the key business opportunities and risks that will present themselves as industries transition to net zero emissions. I hope you learn to discover the best available technologies that will be required at scale to successfully mitigate catastrophic climate change. You will learn what the likely changes on construction sites will be in the next 10 years and what that might look like, and therefore assist you to plan for the operational changes and anticipate what might be coming.
Infrastructure is the great enabler. With it, we have access to essential services. We are connected to the people and places which bring us joy. It ensures our well-being and provides the means to get to and from our workplaces, even virtually, making beneficial life possible.
Across Australia, it's estimated that infrastructure contributes to about 70% of national emissions, with about 15%, which is 87 million tonnes of carbon dioxide per year. It's also estimated that the Australian government will spend $166 billion on infrastructure over the next 3 years.
So the opportunity through construction of new infrastructure to really have a significant impact on net zero targets is absolutely enormous.
Commitment, collaboration, and continuous improvement are key. Infrastructure is conceived, planned, designed, delivered, operated, and maintained through to end of life by an ecosystem of public and private sector organisation and businesses. The best gains are achieved when that ecosystem works together and is enabled by good policy and procurement practices.
The 24 projects certified by the Infrastructure Sustainability Council using the ICE rating scheme over the last 4 years reduced their whole of life cycle emissions by 26.5 million tonnes of carbon dioxide equivalent.
It's fantastic to see that sustainability and impact is now becoming the mainstream conversation in business, as opposed to a side project or a PR good news story. There will absolutely be benefits, both financial, through reduced lifetime costs, and of course leaving the planet in better shape for our kids.
So that video contains the CEOs of 3 industry bodies and a regional director from Autodesk in Australia. And it's accumulation of a body of work undertaken by Autodesk with these industry leaders over the last 12 months. Now, these leaders weren't the only ones involved. And before we jump in, I want to acknowledge all of the people who were involved in this particular project, which I'm talking about today, particularly Andy Cunningham and Sumit Oberoi, Brett Casson and Cara Christophi in Australia, as well as the policy, communications and management teams from the industry associations. And what we're going to talk about today is the background to this, how it came about and the journey of the creation of it and the associated paper that was written. We're going to talk about some of the things that we learned in the paper. And finally, we're going to talk about what you can do about that in your business and in your roles. Now, I guess there's a bit of a backstory to this politically, economically, and for me personally. Politically, what was happening at the time in Australia was the debate around whether there would be or wouldn't be a net zero target. A lot of fear, uncertainty, and doubt at a political level and also pushing that into an economic challenge. At a personal level, we were coming out of lockdowns that had been going on for quite a long time. And I have been working in the sustainability sector for a long time, and working in digital engineering with digital engineering leaders, and seeing recently that these two parallel disciplines are deep and rich, but not necessarily integrating. And the value and the opportunity that presents itself from integrating. And what we set out to do was not necessarily tell government what to do, because there were a lot of parties saying that there needed to be a net zero target, and that wasn't what we set out to do. What we set out to do was to tell industry and government what's already being done. And that journey, I would say, was not necessarily a straight line. In the early days of the collaboration, there was a lot of discussion about the challenges that the construction sector faces, that are not insignificant. The profitless boom and the industry pressures, the consolidations and declining margins, the cultural issues, and exacerbated in some countries by a lack of diversity and innovation, and the contracting models which inhibit innovation. But then we looked at some of the benefits in the sector as well, and the continuous improvement that's possible through the types of learnings possible through the project delivery cycles, the benefits of mega projects in terms of their ability to have coalitions of organizations learning rapidly from each other. And what we learned was that we needed to focus. There was a lot of problems to solve, and what was one of the biggest challenges for industry, according to the CEO from the Australian Construction Association, was understanding what net zero would mean for contractors beyond the buzz and the jargon. So where we started as our underlying assumptions were that there are commitments in place, and these commitments are supported by investors. The institutional investment, data around institutional investment supporting this is undoubtable. The underlying assumptions that we started with here were the commitments are in place, and they are being supported by the institutional investors and the infrastructure owners. The change is here. The uncertainty is more really about what it will look like between now and 2050. From here to 2050, in terms of major capital investment, well, that's 3 major cycles of investment. But for your business, what does that look like? And so there's lots of different types of investments, lots of different types of businesses involved in this sector. And we wanted to start out with having some principles that would underpin net zero success. And these might appear to be a bit airy-fairy, but they were also deemed to be critical to achieve net zero. And that was commitment, collaboration, and continuous improvement. And commitment was seen to be critical, but not necessarily in a way that was defining an ideology. In some ways, it was seen that removing the ideology from this would make it easier, because you're not then having to convince people of why they're needing to do it. The commitment is to meet the market demand, the market requirement, which has changed. And the collaboration is a challenge based on some of the things we talked about before. But the industry has improved in its ability to coordinate and to cooperate, and in many instances has demonstrated the ability to collaborate and share value. And continuous improvement isn't anything new for people in business. Denning came up with it over 50 years ago. Adaptation, and change is critical in business. But what is different here is the FUD, the fear, the uncertainty, the denial in some ways about what this will actually look like. So if we start at what's the current state look like, it might help. And if we look at the current state for a typical infrastructure project in the construction phase. This is where you would see the carbon emissions. Now, this might differ in terms of the proportion from different countries and different infrastructure project types, but in the most part, it won't differ between the categories that we're seeing here. And this is for a road project. If it were for a rail project or for a bridge project, we'd expect to see more steel in the overall ratio. But in terms of the categories, it would be largely the same. And what this is comprised of, in the most part, is the concrete, steel, asphalt, and construction processes. So your on-site haulage and so forth. The transport materials and the other, including waste. And so if we start at a typical baseline, where are we going to see the changes, and what will that look like on a construction site? So collectively, it was determined that it would be useful to look at the enablers. What will be driving these changes? And while it was identified that there was a range of them, including policy and procurement, we didn't necessarily address policy and procurement in this paper because they were deemed to be responses from government and owners rather than from industry. And government and owners weren't at the table for this, it was industry. So really it was us from industry saying, what does the current scenario look like across all of these different enablers, and what can we do about it through to the future? And it was also really just acknowledging that this isn't a silver bullet. It's not going to be a technology fix, or that there's going to be a replacement for steel and a material fix, or that by collaborating and building capability in one particular area that it's going to be fixed. There is a whole range of different enablers that all need to work together to make this change. And we looked at what the options for change and action would look like. From any infrastructure project, we developed this framework that could be applied. And it is loosely based on PAS 2080 that some of you might know, where it goes through a project life cycle and the different options where doing nothing at the outset is the best way to save emissions, and then being more efficient and optimized through the process. But this really just put in place a set of actions that are not necessarily linear, but they are largely relevant to all projects, but they're not dependent on one another. So at the outset, there is a requirement to rethink whether there is a solution that's required. There will be a requirement to redefine the way things are being done, and to look at how we can recover and recycle existing assets, resources, and carbon. Reduce the footprint through efficiencies and productivity, and to then regenerate the climate, landscapes, and biodiversity. Now, these capture options which are often outside of the direct control of the contractor, but critical to put on the table. The contractor and the construction site is often left with what's been designed. And we can't just look at what's being designed and is being built without considering the role of the designer in this, and also the role of those who are electing whether or not there is a project. And there are already good practices and good design value engineering processes that occur. For the last 15 years, I've heard many people say, but this is just good business sense. And the way we do this will become more business as usual. The choice and location of the transport infrastructure, minimizing the number of structures, including ground reinforcement, steel and concrete, optimizing mass balance and the need for transport, optimizing the construction design for less material use, optimizing technical systems and energy and material over the life cycle, and a focus on embodied energy in the materials for being able to elect alternative construction materials, whether they're wood or composites. Now, all of these are becoming standard operating practice on mega projects and are expected to be standard operating practice on most projects soon, and expected to be part of requirements from owners for project delivery. Now, a lot of the themes that you will have heard there around the optimization and analysis, and that really goes to the technology breakthroughs that we've seen. The technology breakthroughs over the last 10 or so years have been around the data accessibility and access to the computing power that will make many of these new methodologies viable. Whether it's offsite manufacturing to drive lower waste or design for deconstruction, integrated analysis or optimization driving convergence, we can see this through manufacturing to the built environment that is enabled through these two aspects, that data accessibility and the computing power. And this on screen is something that a colleague and I put together for, it took about 30 minutes and to inform early decision making on an infrastructure bridge project that previously would have taken weeks of multiple different skills and GIS and land use planning and social, economic, environmental, being able to pull the constraints together to use analysis in the early stages makes for better outcomes as to inform earlier decisions. But how is this impacting the materials on the construction site? Well, there was a very interesting Swedish study that looked at the anticipated changes in construction materials over the next 30 years. And what it found was that across 5 different scenarios, they projected different pathways of what's technologically viable. I think it's interesting and important to point out that they didn't look at the economic factors. They didn't look at the country's specifications and standards and lots of other things that can hold back these change. What they looked at was what is technologically possible at scale. And the study, interestingly, identified that looking at current practices to reduce on emissions, nearly 50% of emissions could be reduced using currently available technologies by nearly 50%. And they identified that the largest savings now would be from the on-site machinery, transport, and asphalt. And the projection is for relative declines that you'll be able to see there through to 2030. And the majority of the most significant decline will be between 2030 and 2045 from the steel. And let's have a look at why that is the case. So the same study also looked at the choices that can be made to drive these changes. And what you'll notice is that the difference between current practice, the reference case, and the best available technology now is significantly from transport, biofuels, and biomass. These were for powering on-site and off-site transport, construction processes, and also biomass being incorporated into the asphalt creation process. What's interesting to note is that the limited options anticipated for alternative product choices, as we said before, around the categories. So we're not really looking for alternative products. It's about how these things are being made. The major changes that we're going to see through the time will be about the mix of asphalts, for there to be warm asphalts and cold asphalt, and also for alternative binders in the concrete, driving the efficiencies. The electrification on site is anticipated from about 2030, when excavators, haulers, crushers, and so forth will be able to be powered by electrification, and then that will be able to rely more on renewable sources. And for those who have been watching closely, there have been some trials successfully of lower emissions fueled steel production processes in the Nordics. And it is anticipated by 2030 that this will be able to include gas recycling and biomass fuel substitution, and by 2045, hydrogen-based production processes. So if we pause for a moment and think about what that means, what are the likely types of innovation that we can expect to see, and the potential rates of change to form this alternative future? Now, when we think about innovations, a lot of the innovations that we've just been talking about are technological innovations that are product innovations. But there are significant amounts of process innovation and business model innovation which will drive winners in this area. Now, I'm not an engineer, but the engineers I know and work with and respect are people who are first class in problem solving. And one of the reasons that you need more than just one type of person at the table is to bring this innovation and problem solving from different perspectives. Power dimensions in the AEC sector are shifting. And if we have a look at how these shifts are occurring, it might give you some indicators of where you can achieve competitive advantage in these areas. So if we look across the different dimensions, we can think about existing techniques or emerging techniques, and existing market requirements and emerging market requirements. And when we think about sustainability, there have been customer requirements to deliver against sustainability for a long time, whether they are in sustainability reporting or carbon reporting, energy management, water management, ratings assessments, and reporting. But what we've seen, as I mentioned earlier, is that in the most part, these have been occurring in isolation. And we've had our designers and engineers and contractors working largely the typical process. And then on the side, we've had these other specialists. The efficiency opportunity and the decision-making opportunity in how these two areas can integrate, bringing the data and computing power that we talked about before together. And while we think that these things might be separate, the fact is that the key decisions that are made by the engineers, whether they're existing modeling, the reality capture, the capabilities that underpin good engineering processes, the simulation, concept design, data enrichment, drainage analysis, CFD analysis, environmental analysis, all of these things can inform how we can get better project outcomes from a sustainability perspective. Now, where there's established industry techniques and existing market requirements, and these have existed for a while, the technology that now and will be coming to market will drive significant efficiencies in the opportunities for companies to do this better, faster. And the challenge that they're going to have is that there are a limited number of experts available in the market to be able to inform some of these decisions from a sustainability perspective, so that relying on technology here will also be critical. Where we see emerging market requirements, these will be service extensions. Now, whether these are new markets geographically or new markets in terms of offering the same services but at different scales, that's something that will be emerging for engineering service providers as well. In terms of new market requirements and new techniques, we're expecting to see new service lines and integrations and convergence across businesses. whether it's delivering rapid retrofits or in-context carbon assessments or rapid early stage assessments. These are new service extensions that will soon likely be business as usual. And finally, where we're seeing emerging techniques and emerging market requirements, this is where companies can get early mover advantage, whether it's from material sciences and developing products, or from integrating across the supply chain for waste and value. There's significant opportunity available there. So coming back to the original intent, the commitment and investment is in place. The technology pathways are clear, and the anticipated change could be rapid. How many business cycles are for your business between now and 2030? If you're in a capital-intensive industry, maybe 3 pivots of investment. But if you're in the technology or advisory space, how much would it take? How long would it take? How are you building the skills to realize the value in this future? Thank you for watching. I hope you have got as much out of this as I have, and I look forward to hearing about your contribution to this outcome.